Today we are both going to learn about solving inequalities, and then we're going to review graphing. So we've already talked about how to graph an inequality, but we have not talked about how to solve an inequality. So we're going to fill in the blanks at the top. Let's look up at the top where it says inequalities can be solved just like an equation, but with a few exceptions. One of the exceptions to this rule is one that we are not going to actually be assessed on, but it is important that you know it exists. Okay? So let's read through the steps to solving one-step inequalities. Again, just like in equations, the variable must be alone or isolated on one side of the inequality. You isolate the variable by using the inverse or opposite operations, just like with equations. Whatever you do to one side, you must do to the other. That is very, very important. This exception number 4 you can circle because it is the one that's important to know, but you're not going to be assessed on because we do not work with negative numbers until Unit 7. But if you were to multiply or divide by a negative number, the inequality sign is flipped. So that means if it was a greater than sign, after you multiply and divide both sides by a negative number, it's going to flip to a less than sign. We will not be assessed on that this year. Make that very clear. Okay? So let's look at number 1. It says n plus 5 is less than or equal to 16. I'm going to isolate the variable by doing the inverse operation. What's the inverse operation of addition? Subtractions. When I subtract 5 from 5, I end up with 0. It cancels out on the left side of the equation. And then I want to subtract 5 from the other side. What's 16 minus 5? 11. So now I'm left with the inequality n is less than or equal to 11. Meaning any number less than or equal to 11 will be a solution to the inequality. Remember when we graph, if it's less than or equal to, it is a closed circle, a filled-in circle. Label the spot where it is at 11. And am I going to shade the values to the left of the number or to the right of the number 11? To the left, because it says any number less than is a possible solution. One way that I remember it is your inequality sign points to the direction that you shade. So look at my inequality sign. It's pointing that way to the left. Therefore, in my graph, I will shade in all my numbers to the left. Solve the next 3 on your own. All righty, what do we get for number 2? What's the inequality you got? Trishti? C is greater than 23. So it's going to be an open dot at 23, shaded to the right. What'd you get for number 3, George? G is less than 4. Open dot at 4, shade to the left. Great job. What do we get for number 4? Ethan? P is greater than 27. Open dot at 27, shade to the right. How'd we do? We are now going to practice writing inequalities for real life situations. So inequalities are often used when we're trying to solve problems. My favorite example of how inequalities work is at amusement parks. Who can think of how inequalities are used at amusement parks? Finn?
By
how tall you are to ride the ride. So you have to be 48 inches or taller to ride the ride. That inequality would be greater than or equal to 48 inches to ride the ride. So let's look at these examples. Number 1 says, Sam is purchasing flags for his flag football team and can spend no more than $55. If each set costs $5.50, then how many flags can be purchased? What do I know? George?
Sam cannot spend more than $55.
Very good. He has to spend less than or equal to $55. So his total cost has to be less than or equal to $55. And I also know that it costs $5.50 for each one. I need to know how many flags he can purchase. How would I write that as an inequality where I can solve for a variable to determine my answer? Think about your expression y equals kx, where k is our constant or our unit rate. Are we being given a unit rate here?
Yeah.
I am given a unit rate. So can I take my unit rate of $5.50 and multiply that times x? What is my x representing? The number of flags that he's going to purchase. And if I solve that, if I do $5.50 times however many flags he purchases, it has to be less than or equal to $55. So basically I just took what we've been doing with translating expressions and I translated an inequality. It's just rain. You guys are fine.
Very hard. Sounds like
Can I solve for my variable x? Yes, I can divide both sides by $5.50. Who thinks they know their answer? How many flags can he purchase? Jack? 10. So x has to be any number of flags less than or equal to 10. So I'm going to graph it, putting a closed dot on my number line at 10. And shading any value to the left. Try the second one on your own. So it says Frances is saving money for a new Kindle. She needs to save at least $200 to pay for it, and she's decided to save $25 per week from babysitting. How many weeks will it be before she can purchase the new Kindle? So we know she's going to she has to save more than or equal to $200, and she knows that she's going to save $25 per week. I want to know how many weeks. What's the inequality that you wrote? Haley?
25 times x equals 200.
Not equals, has to be greater than or equal to 200. Very good. So 25x has to be greater than or equal to, more than or equal to 200. Very good. Therefore, x will be greater than or equal to 8. On your solution, close dot at the number 8. That's a bad number 8. Shade everything to the right to show your solution.